Give it up for this presentation where I'll take you through the basics of software supply chain attacks and what you should be aware of, what tools you can use to prevent these kind of attacks. So welcome everybody, welcome to who you are familiar with some code and will want to get more wise on what you can do to prevent supply chain attacks in software. So I'll be going through some code, I'll be showing you the tools, and that will be happening in 2 parts video. So this one is just the theoretical parts, the more like knowledge, and then you will get some more in-depth security tools testing later on. So I'll just show you some code here. And before that, we need to really, I don't know if you think about it, but we need to consider what kind of attacks can be happening here on our systems. So we need to control the production, we need to control how when we have deployed it, so we need to like test it, we need to look at different kind of aspects of the code if in these scenarios, and when we maintain, we also need to ensure security. So this is just very basic, but you need to consider it in every aspect you can come into it, like where it makes sense in the different kind of like parts of the supply chain. So Sift is a tool. Sift is downloaded, installed. I use it via Brew. Brew installs Sift. So here I'm analyzing my application here called GRC, and the GRC is it's giving me some kind of output here where it shows me that it's analyzing some packages, executables, file digests, and index files. It looks like more or less for just basic stuff here in the packages, and it looks for some versions here. So let's go on, and then let's look at Gripe. And Gripe is also a useful tool here. It's the install here, brew tab anchor Gripe, brew install Gripe, and it can hold up some of it's very powerful here. So it can look all at the dependencies which are crucial in the supply chain. So looking at what is actually supplying your application, what kind of code is addition, extensions, packages are helping your application, and what should you be aware of when you have it. So there are some known vulnerabilities, so it will scan for the vulnerability database here, and then it can go through a lot of your packages, and then we see here that there are no zero critical and 3 high, and so there's something I need to be fixed here in my GRC application here. I have to fix. So another thing we can do is also to test this application, which is available through Docker pull here, Elasticsearch, which has known vulnerabilities, the log4j shell vulnerability, very, very serious vulnerability. So we can run it here, and then we run it with the gripe command here. So the anchor gripe here, the Docker image here with the Elasticsearch on, and interestingly enough, when we run it from this command here, we will get all these vulnerabilities that I get. So this is very powerful that we have this overview of this Docker image, that we can see all these vulnerabilities that are here available, and we'll see the log4j core here. We see some CVEs here. We see some kind of different kind of strings here: critical, severity, critical, high, medium. So it's actually ranking here which one is most critical. And as we saw here, with the command anchor gripe, we get these commands log4j core. So Trivy is also another tool. I'm not going to show that. So let's also look at important stuff here. So what you need to consider when you want to secure code, secure the supply of code, then you should, as a very important part, you get some external reviews. They are independent. They will look for vulnerabilities that you perhaps have not assessed and that you are not aware of existing. So be sure to get external reviewers on this. It can be very helpful. So you can also do some vulnerability assessment. You can use the UpGuard. Yes, I'm just going to show you the tools and the names. You can use some other tools here. Let's just get them on here. So there's Nessus, and I don't know what's the other one called. It's from Rapid7. There's Nessus, and I can't remember the last one, X something. So let's go through what we also can do. We can also ensure that we have pen testing available. So pen testing can be a very helpful way to help you assess and secure the code. So what pen testing will do is they will do code review, and that code review will be will go through a penetration test, and vice versa. So it will be like a circulation of Pinterest, code review, Pinterest, and to ensure that the code is very robust. So if also pen testers, they can also do they also ability to so while they do this, they will do like a recon. So they will set up a reconnaissance. So they will gather information about the servers, perhaps you're running on Docker images, etc., and they will try to gather as much information as possible, or they will just, and that is somehow passively active. So you can also do like when they're browsing the web page, they will be passively looking at the web page, but not actively doing things. But when you jump onto the scanning, and the scanning will be in the active phase. So the active phase will do some nmap scanning, like see what pitch ports are open, which is very useful, powerful to these people, and could be considered illegal if you not have any legal warrant or legal documentation saying that you can go forward with this, an agreement. And after the scanning, they will try to exploit something, and then after the exploitation, the exploit will try to get in. They will try to clean up whatever happened here. So that will be in the loop here, what they will do. Also, and then it will report that to you. So besides doing the code review and pen testing, they can also do these more like outside of the box. So they will go in and they will try to get through your systems. So you will also see some where they will, and this when we consider both knowing that the code we have, and we also consider the last part here where they don't know anything, but they will just gather recon information, and then they will exploit and clean up. This is called the black box testing, where they don't know what's inside, but when they know there's something inside, it's together coupled with the code review and code review pen testing. So that is the white box. They know the parts inside. So if you add these together, more or less, that's called a gray box testing. So if you combine these two things, it's called gray box testing overall, because you're mixing what is white knowing what is inside, having full access with the code review, and then black box is where you don't know anything, but you have to like test different kind of parameters, see what's going on. So also what we need to have in the toolbox here is the static analysis tool, and we have some dynamic analysis tools. So these are fundamental to the work of code reviewing and penetration testing of apps. So that's important. Then we have these tools. We know these. We are familiar with these. They can really be helpful in our job. And what is also important a possibility is that we consider a bug bounty program for a company. So Apple, Adobe, Google, Microsoft, they have these. You can sign up for these today, and earn money if you're able to produce something that is well documented, well reported, have the necessary steps to reproduce your error, and it falls within the scope. They will pay you big bucks, and this is typically done by teams that are professional doing this, and they will get money for that. So they can get 50,000 for some of the lowest paying, and 2 million. Watch my video about mobile security. I will go into who wants and who not wants these payouts. So another, as said before, reconnaissance is also important when we look at getting in. So we'll do some OSINT that is also coupled with the pen testing. So open source intelligence can tell us a lot about some companies, and if we're able to triangulate that, so you have some kind of web browser you go into, and then you can see what tools they're using. You can perhaps use some kind of other information from about the company, about the procedures, who works there, and then you can couple that with another parameter, and perhaps you will get enough information, and you will actually be a threat to their systems. So that's perhaps how hackers work. They will try to leverage different kind of open source available informations in different kind of categories, and then they can use that to like get more precise information and perhaps get an access in. Something other is that we can leverage is fuzz testing, and this is more specific to testing servers, testing code. So fuzz testing is about like doing some fuzzing. Fuzzing is like sending out different kind of signals. So you will try to send some A, B, C strings. You will send some gibberish, something that will match whatever server, what you based on your OSINT. So you have perhaps knowledge about what code has been written in, how they code it. So you gather the information, and then you will try to force it into the to send it multiple times. This will do a lot of the network jamming traffic, so that will perhaps be prevented by most services. But if you're able to somehow leverage the fuzzing without getting detected and sending in information that is well crafted and has, based on the knowledge you've gathered in OSINT, and you can perhaps get some information what is happening in here, how is the system responding if you're getting some error codes, and then you perhaps know, okay, here's perhaps weak link, and you will find something that could be valuable. So you will do that to the web page, and then you could be misusing exceptions. You can use the length of inputs. So if in the code there's not enough exception handling, the length is not taken care of in the black box testing, or you can look at status codes that are, you can get information based on the status code, and then you can perhaps know that, okay, here there's something input looks okay, so you can like try to probe that. So you will like narrow down the scope, and then you will know where to focus your energy after fuzz testing. So you can do some fuzz testing on several applications online. You can try to test that. And you also have some tools here. OWASP set attack proxy, that's a tool you can test on, and you have different kind of burp suite, and so there are different kind of tools available out there. So also what is important to remember, that there are different kind of way get and post, but in essence all communication is the same. So you will there's nothing the communication is communication. So try to probe, get some information, try to do some SQL injection on these allowed attack websites or toolboxes. So talk about SQL injections. What you really should know is that you could circumvent systems. So you'll put in an SQL injection that looks like this: select from users where name equals admin or 111 and password test. So it will look like this, and then you can add some more strings. So, but depending on the system, you'll try to test out different kind of combinations, and then you will get into the servers here. So we have different kind of SQL injections that are targeted towards databases, SQL databases, and there's tautology attack, union query attacks, additional statement attacks, blind SQL injection attacks. Try to do those union attacks, and try to do those. You can look at his videos here, Joe McCrae. And what you also should be aware of, as we were talking about, is the OWASP Top 10. And OWASP Top 10 2025 just been released, and I think they're gonna vote for it. The credentials, or the ones they found recognized is broken access control is at the top, security misconfiguration, so for supply chain failures, cryptographic failures, injection, insecure design, authentication failures, software data integrity failures, and logging and alerting failures, and mishandling of exceptional conditions. So there are parts we were talking about here, and that you should be using to pen test your code. Look for these errors, because they are out there. They know that these are the most vulnerable. So that's where the attackers also perhaps going to focus when they get this knowledge. Yeah. So here's an app here. We show an example here where I've tried to pen test an app. The app here you can download from GitHub. You go to Docker compose up, and it's running the Docker container. We get the Docker container. We try to access localhost 1.0.0.8.0.0.1, and then we get a login page here. The login page works in this way. So it's going to have underneath here we have an authentication table where we store the auth entries, authenticate entries. We have a users table with usernames and password, etc. And these are stored in the database SQL for this app. And then the database .php file is going to have strings that are communicating, code that's communicating with this database SQL file, so where the database are stored. So if we go through a manual code review, we can see here we have the code, and we can see that there's some there's SQL statement here saying, so that is taking an input from the login page and putting it into these variables, so email that pass. And so what we see here, and what we can recognize that we also saw in the OWASP top 10, is that there are no exception handling really here. There's just an else, sorry, we didn't have, but otherwise there is no like exception handling or taking care of inputs or something that is mismatching some kind of behavior that should not be there, unexpected behavior that are violating like normal behavior that could be misusing or the code here. So let's look also here at this very beginning. There's also no input validation before you have the before you are entering something into the database and sending it on here. And also in the register PHP page, we also see that there are issues here with the input validation and no really exception handling here for abnormal behavior. Abnormal automated code review, we go through the SonarQube. I have a video on something about that, but SonarQube online, you select the GitHub repository, you analyze it, we find 2 open security issues and some other maintain issues. So we see here that it's rating it's E, so it's not very good. And it also sees something about here where we are inputting some kind of code here. So I think what it really says here is that we actually, if there's no match, so the way it's inputting here is perhaps very bad, because the match could perhaps like be okay code, but in essence, what is really vulnerable here is that the else statement. So if there are no matches, then we will go in an else statement, and that else statement will eventually allow some more, like to post email, and I'm guessing here, so I'm not really sure, but it seems like there's something with the way it's trying to guess it's interesting to the database. That's only what I think it will do. Or it's not inserting to the database, but it's returning something in a way. So it's not something with the database here, but it's actually just looking at the code here, saying there's something error here. So it's like else, sorry, there's mismatch, get a debug. So it's from some kind of debug message here that's saying like it's a message here with saying that this password and this. So perhaps it's like because it's returning the password in plain text or something, it's using, yeah. So manual pen test. So I think there's a backdoor here that get, if so is one, okay. Yeah, okay, so what we do from a manual pen test. So I found this page, OWASP page, the Burp Suite, I think, but it's taken from OWASP. So if we input this equal 1 is 1, then what happened here is or equals 1 dot dot. I tried to put in that and I got this. So this allowed us to log into the page. I think it's a very simple attack. It's a very known attack. So it must be fixed in every other login page. Thank you very much for watching. I hope you like this video. Like, subscribe, whatever. Dislike if you don't like it.